Good morning, everyone. I'm Karthik Reddy, a student of University of Florida, and I'm here to give a presentation on my project Facial Emotion Detection using Deep Learning for the coursework Pattern Recognition under the guidance of Dr. Depang Wu. Here's today's flow of presentation. I'll be beginning with a brief introduction about the topic. Over the last few decades, the usage of machines in the society has risen. As the exposure to humanity grows, so does the need for smoother and more natural interaction. In order to accomplish this, machines must be equipped with the ability to comprehend the surroundings. In order to interact with the surroundings, machines need to mimic human emotions. Humans basically have 7 emotions, which include anger, contempt, disgust, fear, happiness, sadness, and surprise. Unless one intentionally conceals the emotions, analyzing a human's expression can be an accurate way to determine the true emotional state. Many machine learning algorithms have shown to be incredibly useful in recognition of patterns and categorization. So, in today's study, we look at how the features will be extracted, and by making use of emotion dataset, we can test the reliability of an algorithm. So here's the problem definition. We know that emotions from images can be easily recognized by the human's naked eye. But when it comes to machines, it's a very complex task as it requires the usage of a number of image processing techniques for the purpose of feature extraction. The question is, can machines access emotional states better than us? Now, to answer this, I have built a neural network that can detect our emotional states from our facial expressions. So basically, I've given eyes to the machines in order to recognize our facial emotions. So the entire project is basically divided into 5 stages. The first stage is data acquisition. So the first task is to acquire data on which I will implement the entire project. The model I'll be using should work with a variety of photos. I'll be utilizing the dataset FER 2013, which consists of grayscale images having a resolution of 48 into 48 pixels. The next step is to pre-process the image. When the dataset of the image is binarized, split into trains, validated, and the clarity of the image ridges is increased. The pre-processing technique generally involves the following steps: the reduction of noise, modification of the image's color into binary or grayscale, and the transformation of the brightness of pixels. In this project, to address computer vision difficulties and load a picture from certain location, I have made use of the OpenCV library. I have been using the transfer learning method, and if we want to make use of any deep learning classifiers, then the dimensions must be the same. Therefore, I will have to downsize the images as the ImageNet dataset has images with 224 into 224 size, whereas the FER 2013 has images with a size of 48 into 48. So once the data has been pre-processed, I will be training the model. I will be training the deep learning model using transfer learning. So Keras applications are deep learning models which come with weights that have already been trained. So I'll be using the MobileNet V2, and since we need only 7 classes, I will be cutting down the output. With the help of the relay activation function and the softmax activation function, I will be creating a compiled model that defines the loss function, the optimizer, and I have trained the model for 20 number of epochs to obtain an accuracy of 91.58%. The next step is to detect a face. So the method of converting an image to a normalized pure facial picture is known as facial detection. This mainly involves identifying facial landmarks, detecting and trimming the facial images. So with the help of the hard cascade frontal face algorithm, I have successfully detected the face, which works on gray images only. So once the face is detected, I will have to extract the features. So in feature extraction, specific regions, point landmarks are located and a feature vector is generated. So once the features are extracted, I can classify the emotions. A classifier which is made up of the model and the decision mechanism is used to classify the emotions. I've also manually tested this model by inputting images to it, which I will be showing you at the end of the presentation. Related work and future scope. So one of the globally leading emotion identification firm, Affectiva, has published their work on facial action unit detection using active learning and an efficient nonlinear kernel approximation, where they've used the concept of area covered by the RSC curve to determine the detector's accuracy. When the value when this value is closer to 1, it shows that the classifier is more accurate. So some of the emissions such as surprise and disgust have a higher value of 0.8, whereas anger and despair have a smaller accuracy because of the complex nature. In the research paper, an analysis of facial expression recognition under partial facial image occlusion, Kotsia concentrated on the effects of obstruction when categorizing 6 facial emotion expressions. He made use of multiple feature extraction techniques and machine models to achieve this. So, for future work, psychological signals can be used to test facial expression recognition because these signals are strongly linked to human emotions, and a human has no control over these messages and thereby can't fake expressions. We could also try to determine the intensity of the emotion expressed. So, the performance evaluation of this study is as follows. In the current model, I have implemented facial emotion recognition using a pre-trained CNN model, convolutional neural network model, through transfer learning with the help of the FER 2013 dataset. However, there are few drawbacks. Due to the unequal number of images in different classes, that is, only 547 images in the discussed class when compared to 8,989 images in the happy class, the output gets inclined toward the happy class. Another problem of this dataset is occlusion. So in majority of the images, the individual is either covering his face with his hand or wearing sunglasses, which makes it harder for the deep learning architecture to make accurate predictions. So to improve the accuracy of a model, we could perform dataset correctness, which is a feature selection and reduction technique. We can also make use of facial action coding system or a combination of the facial action coding system with the feature descriptors. We can also test various dataset among different algorithms. This will help us to see if the techniques is the same across variety of faces. To improve the results in the future, a more accurate face detection algorithm with some essential features can also be used. Conclusion and results. So I have successfully developed an image processing and classification method by making use of the facial images from the FER 2013 dataset to predict 7 primary human emotions. The predictor does a good job of predicting test data from the same dataset as its classifier were trained on. However, this predictor rarely succeeds to detect the expression associated with disgust. The main issue with this is due to the lack of training and testing images in this emotion and inadequate pre-training data labeling makes it harder to detect disgust. The classifier also fails to predict emotions for test data using expressions that do not correspond to one of the 7 fundamental expressions, as it has not been trained to do so. Here you can see a few of the output images of the live demonstration, which I will be showing you right now.